Okay, and section 5.4, okay, they call it the fundamental theorem of calculus. And basically, it fundamental theorem of calculus, it relates the derivative to the definite interval. We are not going to go through the fundamental theorem of calculus and go through the proof and all that. We're not going to do all that. I still want you to be able to work the definite interval. So it's going to look very similar to what we did yesterday, and a little bit more practice. So let's look at some examples. They will just ask you to evaluate. So if I give you the definite interval, and it's definite if it's got an a and a b value. So the definite interval of 4 minus 2x with respect to x from -1 to 2. So what you're really doing is trying to find the area underneath that curve, okay, or in this case a line. So remember, if there's no x here, it's actually 4x to the 0. So add 1 to the exponent and divide by the new exponent. And then minus, this is like 2x, so add 1 to the exponent and divide by the new exponent. And remember, I showed you yesterday, you can split this up, but I think overwhelmingly most of you wanted to keep it together, so that's how I'm going to work it. And then you actually write it out twice. It looks like every one of them is going to go to 0, but you write it out twice, and then you sub in your a and your b. So we could simplify. You do need parentheses or brackets. You can reduce the 2's would divide out there, so minus x squared. Okay. Everybody okay with that? Now which one do I substitute in first? The top one. Okay. So we'd have 4 times 2 minus 2 squared. Okay, and then sub in the -1, so we'd have 4 times a -1, then minus a -1 squared. Okay, and simplify. So we'd have 4 times 2 would be 8, minus 4, okay, and then minus. Now this would be a -4. -1 squared would be 1, so minus 1. And then simplify. So we'd end up with 4 minus a -5. So the area should be 9. Okay. So you should be able to do these algebraically. Okay, now we're going to confirm it 2 ways. Okay, and we've already talked about both these. First, put in, when you y sub 1, you're going to put in the 4 minus 2x. It's putting in the original. Okay. Okay, and I would get a good graph of that, get a good window. Okay, so let's just do zoom 6 to start. Okay, and we're looking at from -1 to 2, so that's in our window. Okay, so let's do the home screen first. Let's do FNINT, so that's Math 9. And you can use the vars key, right arrow over to y variables, and y sub 1. And you might want to go ahead and write that down so you know, if you go back to this a couple years from now, you can know what we did. And then we did comma, x, comma, and then you go from -1 to 2. When we do it algebraically, we substitute in the top number first, but when you do it on the calculator, you substitute in the bottom number in that equation. So okay, and that should end up to give you 9 for your answer. So your answer algebraically, and your answer, and what I call this in in the immediate mode. That's the immediate mode to me is the home screen. That's like the home screen. Okay. Okay, now let's do it using the second function calculate. So go back, get a good graph, and then do second function calculate. And we want to do number 7, the integral of f of x with respect to x. And then for the lower limit, we used to just use the trace key, but you should be able to put in the lower limit is -1. And just type it in and press enter. Okay, and it actually marks it on your graph. And then the upper limit is 2 and press enter. And the neat part about this is that it actually shades it for you. So you see a graph like this, and it from -1 to 2. The 2's right there. So it actually shades all of that for you, and then it gives you the answer down below. The integral of f of x with respect to x is 9. Okay, so that's the advantage of these calculators, is it's going to allow you to check your answer. Okay. Any questions on that one? Okay, now just when you think you're getting everything figured out, okay. Oh no. The author, it depends on how the author asks the question. Okay. Let's do another one. Say they ask you to find the integral of x cubed minus 4x with respect to x from -2 to 2. The one thing that I do want you to practice is, can you verbally read that problem? Okay. Okay, so we would take the antiderivative. Antiderivative, we're going to add 1 to the exponent, divide by the new exponent. And same thing, you should be saying that when you're working your homework. Minus 4, and this would be x to the first, so you're going to add 1 to the exponent, divide by the new exponent, and then put parentheses or brackets around their grouping symbol, minus, and then we'd still have x to the 4th over 4 minus, and we can reduce the 4 and the 2 and get 2x squared. Okay, and then you simplify. You sub in the top number first, and it is a lot of pre-algebra arithmetic working with the fractions. It makes you go back. So this is 2 to the 4th over 4 minus, and if we sub in 2 squared, right? And then minus, we'd have a -2 to the 4th over 4 minus, oh, wait a minute, I left out a 2. I left out a 2 right here. 2x2, right? Does that look right? Check my arithmetic. And then that'd be -2 squared. Yeah. Okay. Okay, so let's check as we go through. This would be 2 to the 4th would be 16. Divided by 4 would be 4. 2 squared, remember you got to do the exponents first. 2 squared would be 4, times 2 would be 8. Okay, so in that first set of brackets I have 4 minus 8. Okay, remember if you do this on the calculator, you got to do it in parentheses. Okay, a negative to the 4th power would be a positive 16. 16 divided by 4 would be 4. -2 squared would be 4 times 2. Okay, and should end up, we're subtracting the same thing, so it equals 0. Okay. Okay, now let's do that. I want to do it using this second function calculate. So we need to put it in y sub 1, put in x cubed, and you should know what a cubic graph is going to look like. And I'm going to do zoom 6 to start. Okay. And you can change the window if you want to, but we're going from -2 to 2. Now, can you see why the answer is 0? It is symmetrical, okay? And we're going to have part of the graph above the x-axis, part of the graph below the x-axis. So, what the definite integral, if you're doing that, let's do it on the calculator. Do second function calculate, number 7. And let's go from -2 to 2. There is an area above that's, and your graph ought to look, go ahead and do a sketch of it on your paper. Your graph, if you look at this area and this area, and then it says if you do second function calculate and do the integral of f of x with respect to x, that it is 0. The reason it's 0 is because the definite integral is giving you the net area. Okay, so star that, highlight it. The definite integral is the net area. So the part above the x-axis, this part would actually be positive because it's above the x-axis, and they are symmetrical. So this part's below the x-axis. So when it figures the net area, the definite integral, it gives you 0. Now, here's how the author is going to change that answer. If the author just asked you to figure the definite integral, everything we've done is correct. Okay? Now, change the directions. To say, okay, change the directions to say, find the area of the region between the x-axis and the curve y equals x cubed minus 4x, and our x is less than or equal to 2 and greater than or equal to -2. This is our A and this is our B. Okay. When the author changes the directions like this, he's wanting the whole area, not just the net. The net's because part of it's positive and part of it's negative. Okay, so what you do to figure that is do your FNINT, and we're going to put an absolute value in front. Okay, and you can either use your y sub 1 or you can put in the equation and then comma x comma -2 to 2. Okay, or you can figure each area and then just add them together. Okay, and don't or ignore the negative sign. That's another way to do it. So let's do FNINT. So math 9. Okay, and let's do the absolute values. So that's under the math key, and right over to number. If you need to put that in there, that's the math key, and you right arrow over to number and pick the absolute value, and then put in your equation. Or if you already have it in there, you can do your bars. Yeah. Okay. Okay. And comma. Then you got to still do the variable comma -2 comma 2. Now check. I got 2 lefts. I should have 2 rights. Okay. And now this time it changes our answer. Our answer is 8. So that means this area would have been 4. This area would have been -4. The net area would have been 0. Okay. Okay. Okay, so basically to summarize all this, we're still doing the definite integral. We're still finding the antiderivative. And right now, the only thing we're doing is polynomials. Down the road, we will start doing, like I took you through the product rule, quotient rule, chain rule. We haven't done any of that backwards yet. Okay, that's for down the road. Right now, we're just doing polynomials. So you should be able to do them algebraically. But like on this, it makes a difference how the author, if the author just said figure the definite integral, it's going to be the net area. If the author said, figure the area in between those, then he's figuring it with the absolute value. Okay. Okay. Now we are going to actually add. We have been reading the derivative part of your card backwards. Now it's time to start adding integrals to your card. Okay. So you can share those pins and add. These are on, you can either look up here or you can look in your book. If you open up your books to page 396, these are some of the trig integrals on page 396. Look at that. Table 5.4. Okay. There is actually, this is the one that we have been using for most of the homework. The integral of x to the n power with respect to x. You figure the antiderivative. Now this one, you'll notice on these on the card, they're all indefinite and we're doing the general antiderivative because all of these have that plus c on them. Okay. So this ought to be one of the first ones you add. That's the main formula we've been using. The integral of x to the n power with respect to x equals, you add 1 to the exponent, divide by the new exponent, and then plus c. If they give you an a and a b value, then you sub those in. Okay. Okay. Now I'll give you time to add the rest of those on there. Okay. You can add them from. Do you want me to read them? Does that help or not? Or would you rather just copy them? Just copy? Okay.